So welcome to a plant room tour of a little job we've got on the go at the minute. It's a fairly large house, about 400 odd square meters, 6 bedrooms, 3 bathrooms. And this is the setup we've gone for. We've got a Viessmann 200 25 kilowatt system boiler, obviously running priority hot water. What priority hot water is basically is it's always calling for hot water, and the boiler ramps up to max rate. Got a high gain coil there, and it just always tops up the hot water. Basically, it's like basically a combi with a huge flow rate, I suppose you could call it. Got a hydraulic separation low loss header, and on this system we've got three distinct zones. You've got upstairs underfloor heating, downstairs underfloor heating, and basement or cinema room / gym heating that we don't know what's going to happen down there yet, so we just put the circuit in for now, and when the project gets to that stage we can connect it all up. So how it works: boiler circulates around the low loss header at DT20, and then the underfloor heating I think is designed at DT7, which is a 7-degree difference between the flow and return time, which means that the flow rates are much higher than on the boiler. So if you connected this straight to the boiler, it wouldn't work. So that's why you have the hydraulic separation in. The underfloor heating would be drawing more water than the boiler could provide, and it wouldn't work. So this is the mixer driver setup: mixer driver 1, mixer driver 2, mixer 1, mixer 2, and they basically, because we've got a radiator circuit, these two systems can run these two circuits can run two separate temperatures. So we could have 35 degrees on that flow, we could have 40 degrees on that flow, and we could have 55 coming out of that one. So that's the beauty of this system. You have multiple flow rates, and you can have 3 different temperatures going down each pipework, each run of pipework, and that's what that is. That's a mixer. So that'll suck in 55-degree water from that circuit, and then it will blend it down on the return, and that's the primary flow sensor there to let that mixer know which way to turn and how much water to let in, just to cool that down. And of course it runs off a curve on the boiler. Distribution header, 1.5 inch copper. That's sized to drop the velocity of the water to 0.5 meter a second. So the velocity in these pipes are about 1 meter, just over 1 meter a second. I've calculated them at, and that's all 3 have a similar velocity, but high flow rate. But we need to get the water out the header, not accelerate straight away out the header. It needs to kind of gradually build up the pace. You might have 0.2 meters a second velocity in there. Then the velocity steps up slightly into there because we've got the high flow rate. So that's why the pipe's so big, to drop the velocity from there. And each of these pumps, there'll be a pump there, pump there, pump there, can draw off that header, and the pumps won't interfere with each other. Well, that's the theory anyway. So twin coil cylinder. I've never linked coils together before, so we're going to try it on this. So that coil gets linked to there, flow in there, return off there. Don't know if it makes a difference or not, but we'll see. We'll see. If it doesn't work, we can just take it off and just have a standard coil, and that's it. Viessmann 200 3-zone system, 2 mixed, 1 unmixed.